Okay, so here we are into the Anthropocene. I closed the window because in the previous podcast there was little too much scratchy noise. I didn't re-record it because it's still fairly clear. And you need to realize how global warming is going to affect everything, including my podcast. Okay, so here is a nice plot from Climate Central, which puts out good graphics, which shows the increase in carbon dioxide since the Industrial Revolution, since the beginning of the Industrial Revolution. The seasonal cycle out of it has been taken off, and it shows that a well-mixed, long-lasting greenhouse gas like carbon dioxide has increased monotonically, and it's easy to measure it because you measure it one or two places in each hemisphere and you get a very good sense of the global averages because it's well mixed. On the other hand, temperature has also increased, especially more so in the last 30-40 years, but temperatures have these ups and downs because energy from the sun and that excess energy trapped by increased greenhouse gases mostly goes into the ocean, which has long memory. Some of it goes into evaporating the oceans, melting the glaciers, and so on and so forth. And there are natural variabilities like El Nino and La Nina, which also temporarily release the heat that's accumulated in the ocean and then take it back, and so on and so forth. So natural variability is going to be a large part of the temperature, whereas carbon dioxide shows a monotonic increase, and some people use this to argue that they are not related, which obviously we know from basic physics is not at all true. Especially so because you can look at the emissions, you can use carbon isotopes to say where the increased CO2 in the atmosphere comes from. These are the greenhouse gas emissions by sector. This is from 2019. These data tend to be a couple of years behind because it takes time to get all the data and compile them. So what are the sectors? Energy supply, buildings, transportation, agriculture, forestry and land use, and industries are emitting all these. You find various forms of this pie chart or the contributions from sectors. Energy is large, but the energy also is going into buildings, for example, agriculture and industries, of course. If you then want to talk about the Anthropocene, we can put this in this context where we know that Earth formed 4.6 billion years ago. We went through the Archean, Archaeus, the beginning, Proterozoic, early life, early evidence of life, early forms of life and evidence, and Paleozoic or Phanerozoic is this whole period where there is visible life. And we've been talking about evolution, so along that, biostratigraphy has always been interesting to look at how species have evolved in size, complexity, biodiversity, and so on, and how mass extinctions have affected biodiversity along the way, transition from meteorite crash and extinction of dinosaurs to dominance of mammals and so on. And here we are at the very end, which we are mostly focusing on these days. End of the Pleistocene we already just talked about, and end of the last ice age, and we talked about the Holocene as well. So at some point, a couple of decades ago, Paul Crutzen, a Nobel laureate in chemistry for his work on the impact of HFCs, chlorine, on ozone and ozone hole, coined the term Anthropocene, saying that we are now such a large force that we are creating a new geologic age. It was quickly accepted, and then came the geologists saying we cannot simply introduce a new geologic period without finding stratigraphic evidence for it. So each of these have stratigraphic evidences. So that is now being established, but it'll take some time. Nonetheless, the way to look at global warming and Anthropocene, one way is not to worry about the ups and downs, because year-to-year temperatures will do that. But if you look at decadal averages with respect to some base period, typically like 1961 to 1990, that's used in most studies, then we were below that baseline till about the 1930s, end of the Little Ice Age, and then coming out. And from the 1930s, we began to stay up. There was a little cooling period here, and there was some debate about whether we are cooling, but each decade has been warmer than the previous decade because the year-to-year variabilities get smoothed out when you look at a decade, and that's a alarming number because the top 6 hottest years in instrumental records have occurred in the decade of the 2010s, which is something to really worry about in terms of what we are doing. The other thing that humans have evolved to do now is to impact the environment in great ways. So looking at the greenhouse gases like CO2, N2O, and methane, we have of course increased those, especially since the Industrial Revolution here at 1750 by fossil fuel burning, agricultural activities, draining of the wetlands, rice paddies, increased livestock, and so on and so forth. That has come with the cost also in terms of ozone depletion. I still have some wind, but much reduced, so hopefully not too bad. Climate in the northern hemisphere, average surface temperatures, and we have increased great floods. These definitions have to be looked into, but generally floods have increased, and there is a debate about what causes floods. Is it just the rain, or is it the land use change by humans, deforestation for example, or building on slopes, monocropping, and so on. Ocean ecosystems in terms of a percentage of fisheries fully exploited have gone up. Coastal zone structures in terms of shrimp farm production, millions of metric tons in terms of aquaculture has gone up, has all kinds of impacts in addition to helping food security in many ways and helping poor countries get out of aquaculture. Nitrogen flux, nitrogen cycle has been very heavily influenced by humans, so you can see that in the coastal zone biogeochemistry in terms of 10 to the 12 moles per year, and this has had all sorts of impacts as well. Will Stephan has written many papers on this kind of a topic that you can look up. Terrestrial ecosystems, loss of tropical rainforest and woodland. In terms of percentage of 1700 value as a start, you can see that the deforestation has gone up, amount of domesticated land in terms of urbanization, human settlements, agriculture, and has so on have gone up, and species extinctions in thousands in terms of global biodiversity has gone up, and some people refer to this as the 6th extinction that is going on. The other things to look at, of course, population has increased, but this is complicated as to whether that affects climate change because consumption by few rich people has been the biggest factor. Even as fertility rates drop and people have fewer kids, consumption keeps going up because fewer kids means richer, more consumption. Total real GDP has gone up, foreign direct investments have gone up, number of dams built by human beings have gone up, which affect runoff, ecosystems in the coastal regions, methane and N2O emissions, mostly methane, and so on. Water use in terms of kilometer cube per year have gone up. Fertilizer consumption, total tons of nutrients in millions has gone up. Obviously, we talked about impact of Russian invasion and urea supply in another course that you can look up. Urban population, more and more people now living in urban areas, and this is expected to continue, and urban meteorology, urban emissions, urban energy use, etc. have special place in human impacts overall. Paper consumption, of course, gone up, affects trees and forests. McDonald's restaurants have exponentially increased. Transport, motor vehicles, number of millions gone up. Communication, number of telephones gone up. International tourism gone up. So obviously we are now the sole Homo lineage that survives and having all kinds of impacts. There is vast literature both on the Holocene and on the Anthropocene. I'm just presenting some salient points that I chose myself, but completely personal choice. Greenland is losing billions of tons of ice every year from 2002 to 2020, end of 2019. With the 2003 baseline, you can see how we are using trillions of tons, and there are details of how ponds are forming on top, boring into the a glacier, creating so-called moulins, and creating lubrication at the bottom and accelerating the sliding of the glaciers and melting, and so on. Arctic sea ice is a great indicator of how warming is affecting things. So you look at March sea ice extent in million square miles, and September is critical because end of boreal summer, whatever is left is going to determine the ice albedo feedback and the potential for further freezing in the coming fall and winter months. And March is the maximum sea ice extent you typically achieve before melting starts again. So if this drops rapidly, then this is bad news for rebuilding sea ice through the winter months as well. Meridional overturning circulation that we have talked about a lot has had a signature of global warming. Some debates remain, but this is the temperature trend for years 1870 to 2016 of the SST product Hala SST. So you can see there is a warming hole here, and the immediate argument has been that reduced AMOC or weakening of the AMOC is bringing less heat into this region and cooling it. So this is called the cooling hole. This is the ensemble mean temperature trend from models 1850 to 2005 from one of the models from Germany. Ensemble mean temperature trend for the first 80 years of increasing CO2 at 1% per year, which argues that impact of increasing greenhouse gases produces this AMOC changes and the cooling as observed. And this is the ensemble mean temperature trend for the first 80 years of the 1% per year increase per year in 1% CO2 increase per year, 1% CO2 increase per year in a mixed layer ocean simulation, which basically shows that the cooling is hardly there when you actually don't have the Atlantic meridional overturning circulation. The debates continue as to whether it is just the AMOC or other feedbacks are involved. This one argues that the AMOC is indicated by the red arrow here, the gyre circulation by the blue arrows, cloud feedbacks in the form of reflected shortwave radiation by yellow arrows. Shading represents the surface temperature trend of the 1% CO2 increase per year ensemble. There are also papers arguing that this southern part of the AMOC doesn't have a clear anthropogenic signature, but the northern part does. So where the anthropogenic pull is coming from for creating AMOC changes also continues to be debated, but it remains quite evident that AMOC is being affected, and it's now argued based on evidence that it is the weakest in the last 20,000 years, so 20,000 years since the last end of the last ice age, for example. Okay, so this is the temperature change looking at the AMOC. So there is the North Atlantic current going off here, so you can see the temperature anomalies. This is negative here and positive here, and this is these are the details of the recirculation into Erminger Basin, Labrador Current, how those things are changing in terms of warming. And the East Greenland Current is actually colder. This is various things happening, including Arctic sea ice loss, Greenland ice glacier melt. You would assume that Greenland glacier melt is going to create freshwater forcing here and have an impact on Atlantic meridional overturning circulation, and it does, because if you look at the melt ponds and meltwater runoff created over Greenland here in the southwest corner over the Labrador Sea region, there has been an impact. So remembering that deep water fronts both on this side and this side both can be affected by freshwater and glacier calves glacier pieces being created over these regions. So there is no doubt that AMOC is being affected. It's a question of whether it will collapse and whether which part of the AMOC is affecting the lack of warming in the Greenland, Iceland, Norwegian Sea region. The other thing that we have to look at is things like how GDPs are growing, which we showed. What is the energy intensity of the GDP and what is the carbon intensity of the energy, and how we are moving towards reducing the carbon footprint. So the old IPAT model, which looks at so-called population affluence or consumption technology together to look at the impact on the environment. So I equal to population times affluence times technology. So this is showing planetary forcing, energy consumption and population together, and arguing that we are in the initial growth stage, but we will have to come back if we want to hit the stable point. But we have possibilities of instabilities here. So sustainability trajectory has to come back here, but the collapse trajectories will take us here. These are kind of heuristic arguments, but still important. So this is just a summary of how evolution is looking in the context of the Anthropocene. Humanity's effects on the Earth justify a new geologic time period, some scientists argue. A working group proposes a start date for this epoch, the Anthropocene, in the mid-20th century, a period known as the Great Acceleration, where the warming took off. The group is surveying geologic sediments for the clearest signs of human activity, such as traces of plastics, fertilizer use, and plutonium-239 from nuclear tests. So we are changing, trying to define a new geologic era based on geologic methods, but introducing some new stratigraphic evidences like plastics, fertilizer use, and so on. So here is the human influence on the planet in a very non-linear scale, going back to 10 million years ago when we emerged. So non-linear scale here. Fire, mastering the fire and eating, Homo sapiens out of Africa, megafaunal extinctions, spreading of farming into the Holocene, large-scale mining for Iron Age, Bronze Age industrial revolution, European conquest of the Americas with the Age of Discovery by Columbus around 1492 to 1522, Industrial Revolution kicks off, the Great Acceleration, nuclear tests, and then here we are going into the future. Anthropocene rupture, so this is the disruption of the Earth system in terms of climate change, biodiversity loss, ocean acidification, etc. 4 degrees C warming would take us to the edge of this Anthropocene rupture. Business as usual could take us out here. 2 degrees C warming can keep it down here somewhere, and safe Anthropocene will have to bring us back in terms of the managed Anthropocene. So obviously again heuristic arguments, but nonetheless this is critical to think about in terms of what we mean by Anthropocene and how our evolution has brought us here into the Anthropocene, with everything we do having a carbon footprint, energy intensive lifestyle, and now being aware that we are doing this. So do the cognitive abilities that we evolved over time allow us to realize our ways of life not being very sustainable and start to correct our ways, or are we destined to go on and have collapses as implied by some? So these are kind of interesting arguments, but I'll come back and have one more podcast looking at how we have to worry about combining evidences, especially ecological evidences, along with all the climate and anthropological or human evidences we have been looking at. Okay, it's a good story of caveats. Let me stop this here.